This is our introduction to exercise 5.6 on piecewise functions. As I mentioned, I'm actually wanting to go back and address something that I talked about in composite functions. In retrospect, this formula this rule right here is an oversimplification. Oversimplification. Right? I'm going to go through an example where we've been given functions, right? We have f of x and g of x. And then we're going to restrict our domain to fit this. So this is an oversimplification. Could you please just cross out that first formula? The second one, and the f of g, g of f, they're still valid, of course. The first one's an oversimplification. I'd really like to go into depth so that we know how to tackle these kinds of questions. Okay, so we know, here we go, we know that if we've been provided with an f of x, g of x, we can find f of g, right, by looking at what our domain of f is and our range of g. If you refer back to our formula up here, for f of g, the range of g must be a subset of domain of f. Now, instead of me just spitting formulas at you, remember that the input of our outer function is the output of our inner function. If the range, or the output of our inner function, doesn't exist beyond a certain point, our outer function must be restricted in that domain. Let's look at this example here. For f of x equals to root x plus 2 and g of x equals to log base 2 of x minus 5, let h equal to f of g. I'm going to ignore question A because I'm sure you guys can do that. But for B, we find the rule of h and we find the maximal domain and range of h. Now, the first thing I'm going to do is draw up that table. Okay? So I'm going to draw up the table until we get the f, g, I'm just going to write d for domain, r for range. Right? Now, the domain of my f function is going to exist from -2 to infinity. Okay? The range of that function is going to exist as to 0 all the way to infinity. I'm sure you're familiar with square root functions. The function of g, right, exists from 5 to infinity, not including 5, and goes from -infinity to positive infinity. Now again, let's focus on the idea of f of g. Now we know for our rule that in order for our f of g to exist, the range of our function of g must be a subset, must be within or smaller than a domain of f, right? And if you think about it, the input of our outer function must be restricted by the output of the inside function, which is the output. So, which is the input of the larger function. And so, because of that, for f of g, our new domain is restricted by the range of g of x. Our new range of g of x must be equal to -2, I've run out of space, apologies, -2 to infinity. You can see I've restricted the range of my g of x, which is the input of my outer function, by the domain of f of x. So now, if I have this new range of g of x, I can safely say that the range of g, which is this new one, is a subset of the domain of f. Now, the question I'd ask myself is, what x values give me -2 to infinity? What x values give me -2 to infinity for my original g of x? Now, if I let g of x equal to 2, -2, sorry, because that's my lower range, x, and I'm sure you can solve it yourself, is equal to 5¼ That's just simple substitution, you already know that. So the domain of my function is therefore 5¼ to infinity. So just to recap the steps there, what I've done is I've restricted my g of x range by the domain of my f of x. Okay? Because -infinity to infinity is actually outside of the range or the domain of -2 to infinity. So I've restricted it. So now that my domain of my f of x, the outer function, aligns with the range of the inside function, so it's going to spit something out, it's going to be within, no matter what it spits out, it's going to be within the domain of f of x, right? I get -2 to infinity, but I'm not looking for my range, I'm looking for the x values that give me this range. So then I substitute -2, see what we get. I put in g of x equals -2. You do your own solving, blah, 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 substitution. You get x equals 5 1/4. So that means that 5 1/4 would be the lower range, lower left side of my domain, lower value. Okay, this comes with practice. There is an example of this in the textbook. All right, it just comes with practice. Okay, but the key part to remember is that the input of our outer function needs to align with the range of our inner function, because the range of our inner function is the output. Sorry, the range of the inner function is the input of our outer function. I know, a bunch of words. Hopefully that makes a bit more sense when you get into it. Okay, let's focus on piecewise functions now. I'm sure you're sick of composite functions. If you could go back a couple of pages to example 5 here. So this is on page 18 of your content booklet. Lovely. Okay, so piecewise functions. I believe you've touched on piecewise functions before in the past, haven't you? Yeah, kind of. Okay. We'll take a little from scratch then. Piecewise function, basically, you might have heard of it as a hybrid function. The idea is that we're just combining different functions, except instead of saying we're putting functions together and shoving them, for example, f of x of g of x, right? Instead of doing that, we're saying the domain for this function is here, the domain of this function is here, and just sticking them together with glue, right? It's a combination of different rules for different domain. Let's do a very quick, easy example. Here it says sketch f of x equals 2, and you see 3 different functions with 3 different domains. Now again, instead of trying to do everything from scratch, I'm just going to try and find key points. So I'm going to sketch my axes, and I'm going to say that, well, let's look at the middle one, 2x minus 1, super easy. I know that exists when x equals 0. So if I substitute x equals 0 into that function, I get -1. Super easy. I also know that if I substitute 1 into my function, it goes up to 1. Pretty happy with that? It's a 2x minus 1, so I just connect the dots, easy. That one, middle one's done. Let's look at the one on the left. So the one on the left is where x is going to be less than 0. That function is the first one, -x minus 1. I already know it's negative, so it's going to be a straight line down, easy, we know that. The thing I want to check is whether it lines up in terms of whether it at x equals 0 gives me -1 as well. So I substitute x equals 0, -0 minus 1, perfect, that lines up. The only thing is that I know that this function has a gradient of -1, so it shouldn't be as steep as the one before, so it should look something like this. Pretty happy with that? Yeah. Okay. If I'm substituting x equals to 1, right? Now we know that our function, our third one, which is half of x, is going to be on the right-hand side. Half of x, if I substitute 1, does not give me 1. It gives me half. In order to symbolize the fact that at x equals to 1, it does not follow half of x. In fact, it follows the 2x minus 1 function. I use an open dot, right? So I use an open dot here. That's not a circle. There we go. Open dot to show that. And then it's just a matter of continuing the line. So that one right there, right, would be 1/2. If I was to say, for example, f of 0, it would equal to -1, right? No matter if I use -x minus 1 or if I use 2x minus 1, if I substitute 0, I get -1, easy. If I put in f of 1, I don't follow the half of x, because just like we showed in the graph, it's an open circle, we don't follow that. We look at the one that's got the solid dot, and the answer would be 1. Does that make sense? Any questions about that? So all we're doing is sketching our original functions with different domains. But what happens if we have something that's a little bit less pretty and less easy to do? I'm going to get you to open up your ClassPad, and I want you to go to the main screen. The graphing screen can get very confusing, so we're going to the main screen. For those of you watching the recording, this will not come up, but I'll walk you through what I'm doing. Opening up the main screen, you're going to go to Action, Command, and Define. Has Mr. Wetherall told you how to define f of x before? As a quick recap, you're going to go to Keyboard, Math 3, f of bracket x, and then equals. That's just defining f of x. You already know how to do that, easy. While you're in the Math 3 section, you're going to press this button here that's right under the I in the third row, the fourth column, and it should look like that. Because we have 3 functions, not 2, you're going to press it one more time to get the third function out. Yes?
Can you make this a bit bigger?
I can, but then you'll lose where my buttons are. Yeah. So I'll do that in a second. So once you've done that, now you input your function. So I'm going to make this a bit easier to see for you. Is that easy to see? Okay. So now you're going to put in your functions. Okay. Now in our example, we have x plus 3. And that exists between 0 and 4. But make sure you don't input the wrong symbol. So in this case, it's going to be 0 is less than or equal to x, which is less than 4. You're going to do the same thing for your other functions, 1 over x plus 3. So x minus 3, my apologies. Plus 6, which exists from 4 inclusive of 4. X to 6, not inclusive of 6. I can. And then I'm going to put in my last one, which is just 8 minus 6, 8 minus x, sorry. And that exists between 6 and 10. I'll give you a little bit of time to type that down. Even bigger. I'm not sure if I can make it any bigger, unfortunately. That is the biggest it's going to get. Yeah, that's the biggest it's going to get, unfortunately.
What is the bottom one? Is that
It's just, no, that's just 8 minus x. 8 minus x, yeah. So just to reiterate, it's x plus 3, which goes from 0 to 4, inclusive of 0. 1 over x minus 3, and at the end plus 6, which goes from 4 to 6, inclusive of 4. And then 8 minus x, which goes from 6 to 10. Now the first thing I'm going to do before I hit enter, right, I'm going to double check that there is no overlap of domain. That means even if, right, if I substitute a single value and end up with 2 different functions, I'm not going to accept that, okay? For example, I'm going to double check 4. I know 4 is not inclusive for the first function, but it is inclusive for the second one. Great. 6 is inclusive in the third function, not inclusive in the second function. Great. All right, let's move on. So I hit enter. It should give you the word done. Pretty easy. Now all we need to do is go to our graphing. So if you go to your graphing screen, graphing table, and just type in f of x. And you graph it, it will give you your function. Note that it doesn't have the open circles, right? Because it's assuming that you're familiar with that, but make sure that you understand where those circles, open circles, closed circles are. And that will give you a function. Now, of course, the domain of this function is pretty easy. It just goes from 0 to 10. You know that. You can just look at the original function, right, which goes from 0 to 4 to 6 to 10. Done, 0 to 10. But the range of it will depend on this, right? In this case, I can see the highest value is looking to be the intersection between my first and second function. So I'd substitute, right, because I know it's 4, right? Substitute x equals 4, see what I get. And that would be the highest value on my range. You seem a bit lost.
I don't know. Just graphed it and it just counted.
Thank you for reminding me. Something that you might not have learned in the past, right? If you're using a calculator and your function looks completely different from what you're expecting, right? It's probably a zoom issue, or it's a setting issue with like radians, degrees. If it's a zoom issue, the first protocol for me is I go to Window, not window, sorry, zoom, my apologies, zoom in the top left of the screen. Make sure you've selected and highlighted the graph. You're going to go to zoom, you're going to go to the very bottom one, and then click the very bottom one again. That'll just bring your calculator to what you get blank, like just fresh, quick, standard, that's it. Right? And if your function is completely different, I'll do it again. If your function is completely different, you might have to change your zoom afterwards. But again, my first protocol, if it looks really weird, zoom, quick, so the zoom, and then very bottom one, and the very bottom one again. So quick, quick standard. And that'll bring it back to your original one. So no matter how far you zoom in, no matter what you zoom into, right, you can do the same thing, zoom, quick, and quick standard. I'll come to you in a second then. Any questions about that? I'm aware of the fact that I've been talking for too long.
Is the second function 1 over x minus 3?
1 over x minus 3, and then the right plus 6. Yeah. I'll show you that screen in a moment, yeah?